Hello, in this video we are going to be looking at New York State Regents exam questions that revolve around quadratic word problems. Those problems will be specific to quadratic graphs and parabolas. So let's take a look at a few of our examples here. In this first one, we're letting h of t equal negative 16t squared plus 64t plus 80, and that's going to represent the height of an object above the ground after t seconds. Determine the number of seconds it takes to achieve the maximum height. So we're looking for maximum height. Now it also says justify your answer. When you see that on an exam, that means you're going to want to show some kind of work. If it says explain, you need words, but if it says justify, you need to have some algebra there, some math work with it. Now, if you want, you might want to take advantage of the fact that you have a graphing calculator. So what I'm going to do is I'm actually going to type this in. So negative 16. Your t would be your x. Time is typically your x value. So I'm going to type in x squared plus 64 x plus 80. Alright, so looking at this, it's a little hard for me to see, but I'm wondering if I can scroll all the way up here. Whoops. I'm going to keep going. This thing goes pretty high, and we're looking for the maximum height. If you just tap this right here, it looks like our maximum height is at 144. Okay? So it looks like my vertex, if I just touch this, my vertex looks like it's 2, 144. I actually have the answer, which is wonderful. But I do need to justify. So that means I'm going to have to show a little bit of work. If you remember, we need to find the center. So this parabola looks something, whoops, let's put that down, looks something like this. Okay, oh, that's a very bad drawing, but you get the idea. And we have the axis of symmetry that goes down through the middle. So we're going to use our equation x equals negative b all over 2a. And technically speaking, my x value is t. So if we want to be really correct here, what we're going to say is t is equal to negative b over 2a. So t is equal to, now your a value is going to be your leading coefficient. Your b value is going to be the coefficient on the linear term. So that's going to be negative 64 all over 2 times negative 16. So that's going to be t is equal to negative 64 all over negative 32, which is positive 2. That's exactly what we saw on our Desmos app. Now I'm going to take that 2 and I'm going to put it in. So in place of my t, I'm actually going to put in 2. And that's how I'm going to get my max height. So I'm going to do h of 2 is equal to negative 16 times 2 squared plus 64 times 2 plus 80. So h of 2 is equal to negative 16 times 4 plus 128 plus 80. So h of 2 is equal to negative 64 plus 128 plus 80. And if I add all of those together, I get 144, which is exactly what we saw in the app. And we're looking for the height, and I do not see a unit on it. I'm looking to see, it says represents the height of an object above the ground after t seconds, but I don't see whether it's in feet, whether it's in inches. So max height is 144. Okay, state the time interval in seconds during which the height of the object decreases. Okay, well that's good to know. If I go back to my graph, and let me see if I can find it here. So I'm going to go back to my graph here. I want to know when this thing starts decreasing? Well, it's going to start decreasing right here. Right here is when it starts decreasing. Now it's going to continue to decrease until it hits the x-axis. So I'm scrolling down here. It's going to hit the x-axis, it looks like, right here at 5. So essentially, if I go back over to this graph over here, my very poorly drawn graph, I'm going to notice that it touches right here at 5. So it starts decreasing here all the way to here. Now this value right here, as we recall, was 2. So it's decreasing from 2 to 5. Now I'm going to have to explain my reasoning, which means I'm going to need words here. If I needed some algebra, if I'm looking for this point right here, that is a root, also known as a 0, also known as our x-intercept. To find your x-intercept, what you're going to do is you're going to take your function, and you're going to put 0 in right here. So negative 16t squared plus 64t, because your y value or your output is going to be 0. On this axis right here, your output or your y value is going to be 0. So I put 0 in for y. Okay, I'm looking at this and I'm saying, okay, can I actually factor this? Because your methods are factoring, using the quadratic formula, or completing the square. I think I'm going to try factoring, but I'm noticing something. I don't know if you see it too, but I notice that all of these are divisible by 16. And because I don't like the negative 16, I'm going to divide the whole thing by negative 16. So 0 divided by negative 16 is 0. Negative 16 and negative 16, those cancel, and you're left with t squared. 64 divided by negative 16 would give you minus 4t. And 80 divided by negative 16 is actually negative 5. So now this makes it so much easier, because now I can look at this and say, okay, what multiplies to negative 5 that adds to negative 4? So I'm thinking negative 5 plus 1. So t minus 5 could be 0. Oops. Which means t could be 5, right? Actually is 5. And t plus 1 could be 0, which means t is equal to negative 1. So that means my other root over here was negative 1. So I don't want this one. What I want is I want the interval, and if you remember, we can do interval notation. So it starts decreasing at 2 seconds, and it goes to, whoops, and I made a quick mistake, because when we're talking about increasing, decreasing, we don't do inclusive. So it goes from 2 to 5, soft bracket, soft bracket. You could also say in words, it decreases from 2 to 5 seconds. Okay. Now you would also have to explain your reasoning, and what I would do is I would say it starts decreasing at the vertex until the object hits the ground. So I would say something to that effect, but you need to have words in that. Alright, let's take a look at another one. The roots of a function are, so we're talking about roots, they're negative 2 and they are 8. I don't know what this parabola, it's looking for axis of symmetry, and that is what you have with a quadratic equation. So my roots are negative 2 and my other root is 8. So now this thing could be one of two things. It could be a parabola that looks like this, or it could actually be the other way around. It could be a parabola that looks like this. Either way, I want the axis of symmetry. Now you'll notice something, that your parabola is symmetric, and your axis of symmetry should be in the middle of these 2 points. So if I count, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces here. What's the middle of those 10 spaces? Well, that would be 5. So 1, 2, 3, 4, 5. This should be the middle right here. That should be my axis of symmetry. So I should have 5 equal spaces on both sides. So 1, 2, 3, 4, 5. Yep, I have 5 equal spaces. So the equation for my axis of symmetry is x equals 3. I had no other choice but to do that question that way because they didn't give me any other information. All right, let's take a look at another one. This one asks which quadratic function has the largest maximum. Okay, well, we have all these different equations, and I think what I would do is I would grab my graphing calculator and let's graph each one. So if we graph the first one, so let's cross this one out and let's type this in. So we have 3 minus x, close those parentheses, let's do another one, 2 plus x, and let's find our maximum. And all you have to do is just touch it. So your maximum value here is 6.25. Okay, let's try the next one. So negative 5x squared minus 12x plus 4. I'm going to hit my, let's see, oh, did it graph it? Yep. Let's find our max value there, 11.2. Alright, so this one's out. Now let's take a look at the choices down below here. So we have a choice right here. I see symmetry here and here, which means my vertex must be in the middle right there. So my vertex must be at 1.5. Now I don't know what the height, the biggest height would be, but it is bigger than 9. My guess is that it's not going to be bigger than 11.2. Let's look at choice 4. Alright, so that's going to be somewhere between 4 and 5. So if that's somewhere between 4 and 5, it's not this choice. So I'm going to say that my max value is going to be choice number 3. Alright, let's do one more question here. This was a bit of a nasty question when this came out, the year that it came out. It says a football player attempts to kick a football over a goal post. So here you have a football player. Here you've got your goal post. And the football player is going to kick the ball and we're going to go over the goal post, or at least we're going to try, right? And it may fall short, it may go up and over. I don't know. So the path of the football can be modeled by the equation where your horizontal distance, where x is a horizontal distance, so this is going to be horizontal. Whoop, let me fix that. Okay, so that's fixed, and this would be height of football. And when both are measured in feet, so both of those are feet, on a set of axes, graph the function over the following interval. Alright, well that's nice. I think what I want to do is take a look at what this is going to look like. So I'm going to pull up my graphing calculator. Now I decided to use Texas Instruments for this one because Texas Instruments actually gives a better input-output table. Now I'm looking at this picture here and it's nowhere near what I need it to be. This only goes up to 10. So I think what I'm going to do is I'm actually going to, let's change this here so you can see a little bit better. You see I typed it in, but this only goes up to 10. So I'm going to change my window. I'm going to go to Menu. I'm going to change my window. Now I'm actually going to go to Window Settings because they told me that I need to graph this from 0 to 150. My Y values, I don't know what those need to be, so maybe I'll go 0 to 150 on this as well. Okay, so clearly 150 is way too high for my Y values, but it's right on with my X. So you can see the path of the football. Let me just fix this here. Windows zoom, zoom setting. I don't know, maybe we can go, let's just go to 100. Let's see what that takes us to. Not great, but that's okay. I don't really need to have anything better than that. I'm perfectly fine. Now there's a couple ways or a couple things that you could do. You could go menu, analyze graph, and what you have here is a maximum. So you could do the maximum value this way. So you're going to mark it there, mark it there. So the highest that it goes is 75 feet after 25 seconds. So it looks like the ball starts on the ground, which makes sense because then the kicker's going to kick it. It goes up in the air until it reaches its max height of 75 feet, and then it goes down and hits the ground here. What I need to do is I need to graph this. So I think what I need is my table of values. I need to go up to 150. I'm certainly not going to make a list of all those values, but when I start scrolling through, I notice like 15 has an output of 9. 30 has an output of 16. 45 has an output of 21. It looks like every 15 you end up with a lovely whole number as an output value. So I think I'm going to make a table and just copy down those numbers right off of my table here. Okay, I'm going to pause the video so I can do that. Okay, so I made a nice list from using my graphing calculator. I can see that my vertex is right here, so that's going to be my max height. And now what I'm going to do is I'm going to figure out how to graph this. I have to go from 0 to 150. Believe it or not, there's actually 30 boxes here. So it looks like I can count by fives, but what I think I might do is just mark every 10. So 10, 20, 30, 40, and so on. And I'm going to have to go up as high as 75 or 80 over here. So I'll have to count and come up with my scale. So I'm going to again pause the video so I can do that. Okay, so I have my axes set up and I have my scale. One of the things I noticed is that I probably misspoke when I was talking it through, and I probably was saying, I think I said that the max height was actually 75. No. The horizontal distance is 75 feet away from the kicker. The max height that the ball reaches is 25. So I got to be careful when I speak. I noticed that as soon as I was setting up my scale here. So now I'm just going to plot my points. So again, I'll pause the video to plot those points and we'll answer our questions. Okay, I have my points plotted. So now I'm just going to draw my parabola, try not to make it look like a V, trying to make it look like a nice parabola, and there you go. So I've graphed it. So the requirements for Regents to graph a quadratic is you do need to have an input-output table, but feel free to get that input-output table off of the graphing calculator. Now I also used my graphing calculator to get my axis of symmetry. I don't know about you, but doing the negative b all over 2a with that looked a little on the messy side, so I went with the graphing calculator on that, and that's perfectly fine to do. So now determine the vertex and interpret the meaning of the vertex. So our vertex is 75, 25. You have to determine what that means, and what that means is the ball is 75. When the ball is 75 feet away from the kicker, it's 25 feet in the air. So I'll say that again. When the ball is, because this is your x value, which is horizontal distance, so that's the horizontal distance. If I go back up to my picture here, that's the horizontal distance. So that means this is 75 feet away and the ball is 25 feet off the ground. So I'm just going to tell you that in words. But now let's go down to the next one. It says the goal post is 10 feet high and 45 yards away from the kick. Will the ball be high enough to pass over the goal post? Justify your answer. Okay, so the goal post is 10 feet high and 45 yards away. 45 yards away, that's my x value, and this would be my y value. I'm actually going to plot that point. So 45 yards away would be here, 10 feet high, would be here. Okay, so I plotted the point. Will the ball be high enough to pass over the goalpost? And the answer to that is yes. The other thing that you could do, it does say justify your answer. So one of the things that we could do if we wanted to is we could take the equation. So if I were to take the equation and copy it down here, so we have h of x is equal to negative 1 over 225 x squared plus 2/3 x. And I put in, so you got to know which one's your x value. Your x value is 45, so I'm going to put in 45, and I'm going to see what I get out as an output. Okay, I'm going to punch it in my calculator. Okay, so I did this as an example of how you could justify your answer. One of the things that you will notice is that we actually already had the math done. It came from our table of values. So when the ball is 45 yards away, it's actually 21 feet in the air. It's 21 feet high. Plenty high enough. If the goalpost is 10 feet high, this is plenty high enough to pass over that goalpost. So the kick is good. This was a tough question the year this came out. What I'd like to do is I'd like you to take 20 minutes. I gave you some practice questions. So your independent practice is going to be to work 20 minutes on the additional questions. Don't feel like you have to finish all of them, but 20 minutes. Use your graphing calculator as much as you want. Things that are non-multiple choice, you should probably try and do using algebra, but feel free to get comfortable with your calculator. Use it. It's your tool. I want you to be able to use it. So good luck with that. 20 minutes on those extra problems, and then you can stop there. Good luck.